Sorry. Okay. This is just, the 1/2 is just on this bit, and then the total parentheses is squared. Okay, so why is it squared? Let's start there. Yeah, I had a two-site mechanism, and in the previous version that I wrote down, I've got 2 stars. You see they're in both places, so you just factor them out, and they become L star divided by all of this stuff, right? And then this represents what? What does this represent? Yeah, this one's simple because it's just the adsorption, desorption. This one, and this more complex expression, R. The one thing I'll point out, because it bothers me, this Kr is actually the equilibrium constant for the consumption of R. Normally it's weird to see, like, you know, K, Ke, E, Kh, H. And then this Kr, but that's just because that step, what we assigned for equilibrium constant R was the consumption of R. So that makes sense, that the larger that equilibrium constant, the less R on the surface there would be. What produces R? Ethylene can produce R, right? So that goes up. And then if I put in more hydrogen, that also increases the amount of R on the surface. Because again, the R is produced from ethylene in the quasi-equilibrated nature of this reaction. I erased them all, but that's where the R comes from. So any questions? Yes? So it's odd to me that, so where does R come from within this reaction network? What makes R? R makes R? RH makes R. But if we look at, this is the species, this is the terms which represent R on the surface. And you don't see any pressure of the alkane in there. Instead, what pressure do we see? Yeah, so I mean that should give you a hint that this is the rate limiting step, again, where R actually comes from, or I think a much better way to describe it is, what determines the coverage of R on the surface? Well, that is whatever it's in equilibrium with. And if you go back and you look at the reactions, what it's in equilibrium with is E plus 1/2 a hydrogen molecule in the gas phase. Now, that's not written out in a single step, right? That's written out in 3 steps. But you can add up equilibrated reactions. Equilibrated reactions are independent of state. So if I write an overall reaction, I get R star is in equilibrium with E in the gas plus 1/2 hydrogen in the gas. Put my parentheses in the wrong place. Plus a surface site. Right? So in other words, even though R comes from the alkane, that's my reagent, what determines the amount of R on the surface is actually both ethylene and hydrogen, which is why if either of those pressures go up, this term gets larger, meaning that the coverage of R on the surface goes up. Okay, the question goes on to say, at low temperature, the dissociation of ethane, or I said the dissociative chemisorption of ethane, is effectively irreversible. And adsorbed species R and H do not further react on the surface. In this case, the adsorption step may be represented by governed by the rate coefficient Kc. Write out an equation in terms of the ethane partial pressure and other known quantities for the rate of ethane's dissociative chemisorption in the limit of zero coverage of all adsorbed species. Okay, where do we start? It's an irreversible reaction, and it says that R and H do not react further on the surface. So it's asking me for the rate of, I assume, ethane consumption, rate of ethane adsorption, ethane consumption, same thing. Where do I start?
Desorption of R.
Desorption of R, what?
It said it doesn't react. You have to desorb them.
It says they don't react.
Why don't you just write the
Let's start with just the rate equation. Don't get distracted by the color. So the rate of this reaction is what?
RH and star square.
Yeah, you're leaving something out.
K, that's right.
Little kc, which was given, times the pressure of RH times concentration of star squared. Everybody get that? Nobody's confused by that? Okay. Now what? Am I done? No.
You need more equations. You need the desorption steps and the site balance.
Why do I need desorption steps? What am I missing?
When you start doing the site balance, you're going to have more of these.
Okay, am I? So let's do the site balance. L is equal to star.
Never mind.
What's that?
I said no, you'll be able to just say the zero.
In the limit of zero coverage of all adsorbed species. Hey, isn't that nice? I think that's it. Yeah, that's it. My best guess is he was just trying to distract people with color on that one. Yeah.
No, that's like not part of any reaction. It's just then you don't have to like start with a catalyst at that point.
It's not, no. But yeah, I can still calculate the rate of adsorption, assuming that at these conditions I'm irreversibly adsorbing something. All right, the only time that the other reactions matter is if they're equilibrated or if I'm not, if it's a reversible reaction. Of course, this can't continue forever. My surface will fill up, my rate will go to zero. But in the limit of zero coverage, this is the rate. So again, this is only valid at zero coverage, right? Once I do this approximation, this is only valid at low coverage, which may not last very long if nothing can further reacts. I expose a surface and it fills up pretty quickly. But you don't have to worry about that because the problem said to do this, and so that's what we did. Okay. Ethane can also dissociatively chemisorb by a two-step process. So we had a one-step process before. Now we're going to look at a two-step process where first RH comes in, and he's drawing it as not requiring a site, and that's fine. So think Physisorb. And he doesn't want to say that Physisorb sites are sites, so he doesn't draw sites. And then the Physisorb species reacts with two sites. And in an irreversible step forms R star plus H star. He gives here little ka and little kd, I assume meaning for the reverse reaction. And here he gives little kc. Says, yeah, where Ka and Kd are rate coefficients for adsorption and desorption for species RH. Derive an equation in terms of ethane partial pressure and other known quantities for the rate of dissociative chemisorption and the limit of zero surface coverage of adsorbed species. And then it asks, what is the effective rate coefficient for ethane dissociative chemisorption according to this mechanism? So where do we start? Rate equation. Okay. For which reaction?
specify that the, RH is theoretical surface?
Sure.
Is that AD for absorb?
Yeah, just to match what
Would
was
you say
said.
star?
Hmm?
What is that the same as star?
And he didn't give me a star. He told me I had to. I think this problem was really just to try to trick people up. Math is not hard. Okay, it had the same clause in the limit of 0 adsorbed species. So what can I go ahead and do to that star?
Also,
Okay, now how do I relate that then to RH? I don't see anything that stops us from doing that, but his solution doesn't do that. He doesn't tell us that. He does tell us the adsorbed RH molecule is a short-lived intermediate. Yeah, so let's do that instead. If I don't want you to use quasi-equilibrium, I'll tell you not to use it. He left it a little bit more vague.
But if you have
So-
steady state, couldn't you use equilibrium constant anyway, 'cause it's the same thing?
No, it is not the same thing. It's maybe good that we did this. Okay, so let's do PSSA on RH adsorbed. So what is then equal to 0 if I'm applying the PSSA?
The net rate of